Okay, welcome to Unit 3, Lesson 3. We're looking at the quadratic function, which makes a parabola shape when graphed, and a parabola looks like a U. You can see the two U shapes on the graph, one that opens up and one that opens down. So a parabola, or a quadratic function, always has some certain key features. One of those features is that it has a maximum or a minimum point, and that maximum or minimum point is called the vertex. In the red one, the vertex is the maximum, and the vertex point is at 2 and 5. In the purple parabola, the vertex is a minimum because it is the lowest point, and it is at 0, 0. So when a parabola opens up, its vertex is a minimum, and when a parabola opens down, its vertex is a maximum because it is the highest point. A parabola is symmetrical on each side of the vertex. That means it looks the same on either side of the vertex. This is called the axis of symmetry. The line that splits the parabola in half so that's the same on both sides of that line. The axis of symmetry is in the middle. So in my purple parabola, the axis of symmetry is on x equals 0. On my red parabola, the axis of symmetry is on x equals 2 because it goes through 2 on the x-axis. In addition, parabolas can have different shapes that have different steepness. Both these shapes look like they're about the same steepness. But if I drew a parabola like that, it's still a U shape, but it's much, much wider. So it's not as steep. It's going up more slowly. The steepness is affected by something called the step pattern. For the most basic parabola, our steps mean I go over 1 and up 1, and I go over 1 and up 3, and over 1 and up 5. And the parabola mirrors that on both sides, so that we have steps up of 1, 3, 5. In fact, your basic step pattern is over 1, up 1, over 1, up 3, over 1, up 5, all the odd numbers. Parabolas are used in the real world in many places. Roller coasters have U-shaped tracks. Bungee jumping, when you jump off a bridge, makes a U-shape, part of a U-shape. Target shooting, when you shoot, you have a very wide parabola. The path of a swing, you swing back and forth and make a wide U shape. Anytime you throw, kick, or hit an object, that is a parabola. If you kick a soccer ball, it goes through the air in a wide U shape. Any archways that support buildings are always in a U shape. So this is the same parabola shape that has the key features we talked about up here. They have a maximum minimum point, they're symmetrical, and they can have different steepnesses depending on their step pattern. Quadratic functions are often written in the form y equals ax squared plus bx plus c, or f of x equals ax squared plus bx plus c. F of x being our function notation. Both those are in standard form. We call it standard form of a quadratic. The key thing that tells us a quadratic function is to have an exponent of 2. So a quadratic function always has an exponent of 2. To graph a quadratic function when it's in standard form, we want to make a table of values and then we put those points on the grid. So we're going to look at a couple of examples together. So if I want to graph this function, I'm going to make a table of values. That means I choose numbers for x, like -3, -2, -1, 0, 1, 2, 3. And we substitute those values into our equation to get the y number to make a point for the graph. So if I substitute it in, I have -3 squared minus 3 times -3 minus 4. Means my y value would be 9 plus 9 is 18. Take away 4 would be 14. And I do it again for each x number. 2 squared minus 3 times -2. So I've got 4 plus 6 is 10. Take away 4 is 6. And I do it for -1. Go ahead and figure your own out. I'm going to put each number in there. And we're going to get each pair for the graph. So when I substitute -1, I have 2 plus 3 is 5. Take away 4 is 1. When I put 0 in, I'm going to get -4. When I put 1 squared or 1 in, I get 1. Minus 3 is -2. Minus 4 is -6. And 2 squared is 4. Minus 6 is -2. Minus 4 is -6. And 3 squared is 9. Minus 9 is 0. Minus 4. And so then I put my numbers on my graph. So I put my numbers on my graph. I'm going to need a bit of a scale. What have I got? 1, 2, 3. 1, 2, 3. And I need to go up to some pretty big numbers. 1, 2, 3, 6, 7. 2, 3, 4, 5, 6, 7. And -2. All right. So I put my points on. -3, 14 isn't going to fit, so I'm going to leave that point off for now. -2 is 6. 1, 2, 3, 4, 5, 6, and -2. There we go. -1 and 1. 0 and -4. 1 and -6. 2 and -6. 3 and -4. So because of the nature of our parabola, we know that it's going to have a U shape. So it's going to be symmetrical. And we see the start of our U. What we need to figure out is where our vertex is. So if I want to figure out where my vertex is, because it's symmetrical, these 2 points are the same distance away from the vertex. So I want to figure out a point right in the middle. So those 2 points at -6 are 1 and 2. So right in the middle of 1 and 2 is 1.5. So I'm going to put 1.5 into my equation, and I'm going to find out my vertex once I grab my calculator. So we have got 1.5 squared minus 3 times 1.5 minus 4, negative 6.25. So we're just a little bit lower. So I can draw the rest of my parabola. There we go. So state the domain and range. We've been working on domain and range. Domain are all the x numbers and range are all the y numbers. We've looked at a few forms for domain and range. One way to write domain is we're looking for a set of numbers. So for my parabola, the domain is all the x numbers. And if I think of my parabola, it's just going to keep getting wider and wider and wider and use up more and more x numbers. So we say that the domain x is any real number. The range is all our y numbers. So if I look at my y-axis, the y-axis, the graph starts right here, and then it gets bigger. So right there is our vertex. So our y numbers are bigger than or equal to negative 6.25. There's our range. Second example. Graph the function, state the domain and range, same deal. We're going to make a table. It's just written in function notation, nothing different than the first one. So if I put negative 3 in for x, you can stop the video if you want and figure them all out. I'm going to fill in my table. Oops, not sure why I put 0 there. My brain was not functioning. So when I calculate, negative 3 squared is 9, negative 18 plus 6. 18 plus 6 is negative 12, minus 4 is negative 16. And then we've got 4, negative 8 plus 4 is negative 4, negative 8. And then we've got negative 2, 0, negative 4. And we've got negative 4. And we've got negative 2, negative 4, negative 8. And we've got 4, negative 8, minus 12, minus 16. And we've got 9, negative 18, negative 24. That one's pretty big to be putting on our graph. All right, we're going to set up a scale here. Our x and our y axis. 1, 2, 3, 4. 2, 3, 4, 5, 6, 7, 8, 16. All right, we're going to put our points on. So negative 3 and negative 16. 3, negative 16, negative 2, negative 8, 8, negative 1 and negative 4, 4, 0 and negative 4, 1 and negative 8, and 2 and negative 16. So, like the last time, we can see our parabola shape. And now we need to figure out our vertex. So we know our vertex is going to be between these 2 points. So between negative 1 and 0 would be negative 0.5. So I'm going to put in negative 0.5, and I'm going to figure out my vertex. So I've got negative 2 times 0.5 negative squared minus 2 times negative minus 4 negative 3.5. That would make sense. Negative 0.5 and negative 3.5. There we are. There's the rest of our parabola. To state the domain and range. Domain are all our x values. So if I think of my x-axis, the sides of my parabola are going to keep getting wider and wider and wider and use more and more x numbers. And in fact, that pattern works for any parabola. The domain is always any real number. The range is my y-axis. Now if I see my y numbers start there, and then they get smaller. They go down. So we say y is less than or equal to my vertex of negative 3.5. Okay, so double check your list of questions. I'm going to delete that for a minute. Double check your list of questions you were given and try them out. Good luck with that, and let me know if you have any questions.